Today we're going to be focusing a lot on arithmetic sequences. And as we talked about the other day, arithmetic sequences when we're adding or subtracting the same number each time from the previous term. But we also know that linear functions are adding or subtracting the same value from the previous term. So you're going to see a lot of similarities in there. So an arithmetic sequence, it's where the difference of consecutive terms is constant, and that difference is noted by the letter D, also called the common difference. And again, like we were talking about, you can think of that common difference as your slope. And to find the slope, you can just subtract two consecutive terms. Now, it's important that they are consecutive terms when you subtract them to get your common difference. Now, another new terminology is something called an explicit rule. An explicit rule is a rule that you can plug in any value to, or any value for n, to get that term, kind of like a function. And that's right here. You may say, well, that's function notation. F of n, or f of x, equals 3n minus 7. Well, if I want to find the 12th term, I can plug in 12 for n. That's what makes this an explicit function, or sorry, an explicit rule, because I can quickly calculate a specific term. Whereas a recursive rule that we did the other day, I can't look at a recursive formula and say, give me the 14th term, because that recursive formula will use the term before that, or the terms before that. So you have to go in order. Whereas explicit, you can go right to the exact value. So write the first 5 terms of the sequence. That's just saying, okay, what is f of 1? What is f of 2? And I'm going to calculate these in a minute. F of 3. F of 4. And f of 5. So plugging in 1, 3 times 1 is 3, minus 7 is negative 4. 3 times 2 is 6, minus 7 is negative 1. And 3 times 3 is 9, minus 7 is 2. 3 times 4 is 12, minus 7 is 5. 3 times 5 is 15, minus 7 is 8. So you can also verify to see, all right, we're adding 3 each time to my values over here, which is our, our number in front of n, our common difference. Over here, we're doing the same thing, same directions, but this is just in sequence notation. Ace of 2, ace of 3, ace of 4, so 2 times 2, sorry, 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. 6 plus 1 is 7. 8 plus 1 is 9. And 11. And again, you can verify I'm adding 2 each time, which is our slope. So with these formulas, I can say, all right, what is the 12th term? And like I said, you can just plug in, a 12 would be 2 times 12 plus 1, or 25. I wouldn't have to work my way up like I would with recursive sequences. So we're going to tell whether the sequence is arithmetic or not. So if I look at the first one, I'm going up by 2, up by 2, up by 2, up by 2. Yep, this is arithmetic. The common difference is 2. If we look at this, all right, if I start at 32 and go down to 27, that is subtracting 5. If I go down here, 27 minus 6 is 21. Those are not the same. So no, no, because the difference is not common between consecutive terms. Now, let's say this was minus 5, but then this one was minus 4. It still would not be arithmetic because it has to be the same difference for all of them. Now, down here, what we're going to do for each of these sequences, we're going to write the rule for the nth term, which is that explicit rule, find a sub 19, and then also write a recursive rule to review what we did the other day. So for explicit rules, it's in the form an equals d times n plus b. Or you can think of it as y equals mx plus b. Our common difference, you can see, is 7. But this is not my b value. 2 is not going to be my b value because, remember, this is our first term, second term, third term, fourth term. So when I plug in 1 for n, I need to get 2 as my answer. That's not going to happen if I make my b value 2. So what we're going to do is we're going to say, there we go, 2 equals, our common difference is 7, our n value is 1 plus b. If it helps you to think of it, you could say, all right, what if we had the point 1 comma 2, where this is, instead of x and y, we have a and an, and that's what we plugged in this formula. And we also know that 7 is our d value. So then we can get b by itself. Minus 7 from both sides, negative 5 equals b. So my explicit rule is going to be a of n equals 7 times n minus 5. Okay, now the 19th term. So a17 equals 7 times 19 minus 5. And we type that in the calculator and we would get 128. So we didn't have to go up and do all the other stuff with it. We didn't have to find the 16th, 17th, 18th term to get this. Now, to write a recursive rule, an is going to be, we're taking that previous term and adding 7. And that first term, though, is 2. So this is recursive. And this is explicit. So we could write it in two different ways. All right, now in letter B, we have 57 minus 12 is 45, minus 12 is 33. So our common difference is negative 12. So same idea, we have an equals d times n plus b. And we're going to, if we look at 1, 2, 3, 4, or 4 terms, we can use the term 1 comma 57 and plug those in to find our b value. So 57 equals negative 12 times 1 plus b. Right? 57 equals negative 12 plus b. Add 12 to both sides. You have 69 is equal to b. So now we can write our explicit formula. A sub n equals negative 12 times n plus 69. And then to find the 19th, term, we're just going to plug in 19. So a of 19 equals negative 159. So again, this is our explicit formula. Our recursive formula, an equals, well, we're taking that previous term and we're subtracting 12 from it. And our first term is 57. So this is my recursive. Formula. All right, I want you to try these two problems here. So go ahead and pause the video, and when you're done, unpause it to see what we got. All right, so you can check your answers here. So if you need to pause it a second so you can see what you get, see what you got compared to what I got, and you can see where you may have made a mistake. Every time that you write out your recursive or your explicit formulas, I like to go back through and see if they work. Plug in 3 for n and see, do you get negative 3 in this in your second one, or plug in 3 and do you get 1? I like to do that just to make sure I'm on the right track. What I'm going to do here is I'm going to do both letter A's for these examples and then let you try the other two. So write a rule given a term in common difference. That one won't be as difficult. Because the 11th term is 41. So like the point 1141 is on your graph, is in your sequence, as opposed up here our points with like 1 comma 9, 1 comma negative 15. This time it's 11 comma 41, and our common difference is 5. So our formula, I'll write it up here, a of n equals d times n plus b. Well, a of n is 41, and that equals my common difference, which is 5 times 11 plus b. 5 times 11 is 55. So 41 equals 55 plus b. And when we subtract 55 from both sides, that's going to give us negative 14. Negative 14 equals b. So that means our explicit formula is a sub n equals 5n minus 14. And you can double check that by plugging in 11. And if you do 5 times 11, you get 55. Minus 14 is 41. Now with this example, number 4, you want to treat these two as separate points and use the slope formula. Think of it as 6, 7 and 22, 87. And to find your common difference, that slope formula, x2 or y2 over y2 minus y1, your difference is going to be y2 minus y1 over x2 minus x1. And if it helps you, you can always label these. So you have 87 minus 22 over, 87 minus 7 over 22 minus 6. And that's going to be our common difference. 87 minus 7 is 80. Over 22 minus 6 is 16. That actually reduces to 5. So now that we know our common difference is 5, it is just like this problem up here. We have to find our b value. And you could use any point you want. You could use 6, 7 or 22, 87. I prefer smaller numbers. So now I'm going to do 7. 7 is equal to my common difference, 5 times 6, because that's my point, plus b. So 7 equals 30 plus b. Subtract 30 from both sides. Negative 23 equals b. And that would make my explicit formula a sub n equals 5n, because that's my common difference, minus 23. That is my b value here. All right, so I want you to pause this and try the other two problems here, this solo and this team problem, and see what you get. Once you're done, unpause it and we can check. All right, you can check to see my answers against yours. So go ahead and see that. If you need to pause it to check. Hopefully you can see if you made a mistake where you went wrong and fix that. So thanks for watching the video. Make sure to like it and subscribe.